Okay guys, this is the numerical that we are going to check in. Moment of inertia of a disk of mass m and radius r about a tangent to its rim in its plane is. Now see, we had in the earlier numerical we had talked about this. This was disk, IC, radius, and this is what we had formed. But now what we intend to find is this. It is tangent to its rim and in its plane. So this is the plane. So it is tangent and it's in its plane. Alright. So it's in its plane. Alright. Not normal to the plane, but in its plane. So this is what the situation is. So how can we do it? So here, mind you, two formulae. Both the formulas which we have learned, parallel axis formula and perpendicular axis formula. Alright, we have got to use. So parallel axis formula, practically I intend to show it was about this, and perpendicular axis formula is, now if this is IZ, then this would be IX or this would be IY. If I show you this way, if this was IZ, then this is IX and this is IY. I hope you understood, right? Okay. So in this numerical, what do we have got to do? See, we are starting from here. We know this for disk. We know IC. We know IC for disk is half mr square. That we know. Alright. Now we cannot directly jump here. We cannot go to parallel axis. So we have got to make this parallel to this. So we have got to make this parallel to this. So this is the situation. Alright, this is the situation. This is the situation. So we have got to make this parallel to this. So we have got to find out this. So we have got to find out this. Now once it becomes this, now we can apply parallel axis formula. Alright. So for converting this to this, we have got to use perpendicular axis formula. Alright. So let's get into it. So what we do is, so this was the situation. So this is half mr square. So what would be this? D is diameter, moment of inertia around the diameter. Alright. So ID would be, now obviously when we talk about this we can take it either as IX or IY, both are same. You can say whatever you wish, IX or IY. Fine. Now this, what was given is, this is IZ. So we know the relationship. IX is equal to IY is equal to 2IZ, therefore IZ is equal to half IX. So if I want to convert IZ, to IX, then this is the equation. Half IX is equal to half IY. So if this is it, then this would be half into half mr square. This was half mr square. Half of that, it would be half into half mr square, right? Half is this half mr square is that of disk of IC. Alright. Why IC? IC was IZ. So IZ, so half of IZ. So this becomes 1/4 mr square. So done. Now we can jolly well apply parallel axis formula. So parallel axis formula is what? It's I0. Alright, we know this is I0 around which it is rotating. I'll show you how it is. It is what? IC. Now IC converted to ID. So ID is 1/4 mr square plus mr square, mh square, I written it's mh square. So r, so it is mr square. Again the LCM story. So if you take, now I am sure you are okay with LCM. So it is 5/4 mr square. Alright, the situation was, I can't show it nicely, but try and understand. So it would be rotating like this. Oh yeah, it would be rotating like this. Alright, tangent in the plane, tangent, tangent, and in the plane. Alright, so the answer that we get in is 5/4 mr square. Alright.